Good morning all of you. Today I am going to teach our first chapter, chapter 1 matter. Already we completed this chapter in the online class, but I think so many of you are not able to attend the online class. So this class will be helpful for those students who are not able to attend the class. Okay. So this chapter 1 matter, I am taking this full chapter. I am not able to take the entire chapter with one video. So this is the first video. In that I will cover all the things related to matter, and the second video, it is the second part, second main point from this chapter. It is regarding the change of state, and the third video will be of evaporation. So I will send this chapter, entire chapter, in 3 different videos. So now this is our first video. It explains about matter. Okay. So before starting the explanation, let me say, if you are viewing the video, to get the entire space, you please keep your mobile phones in a layout way, that is horizontal way. Don't keep the mobiles in a portrait or vertical way. Please keep your mobiles horizontal. Then only you will be able to see the entire screen. Okay. I hope you will do so. Thank you. I am going to start the chapter. So first we are going to study about matter. What is matter? Matter means anything or something that which occupies space and has mass. So here you can see a scale in my hand. The scale occupies this much space in this universe. So we can say the scale is a matter. You can see this toy car. This toy car, it occupies a small space in the universe. So any object, it can be either solids or liquids and gas, any objects which occupy space and has mass is termed as matter. Okay. Now we are going to study about what is matter composed of. This matter is composed of tiny particles. That means that much tiny we are not able to even see with our naked eyes. Tiny particles called molecules. Okay, matter is composed of tiny particles called molecules. So here in chapter 1 matter, we are going to study in detail about these molecules. What are the characteristics of the molecule and the molecular movement in solids, in liquids and gases. So there are 4 characteristics for molecules. As we all have different characters, the molecules also have 4 different characters. The first character is they are small in size. Okay, they are very tiny and we are not able to see it with our naked eyes. So we can say that they are very small in size. Second one, they have space between them. In this scale you can see there will be millions of molecules, but between these molecules there is a small space. And they possess kinetic energy. What do you mean by kinetic energy? In class 7 we studied the definition of kinetic energy, potential energy. This kinetic energy and potential energy are the branches of mechanical energy. And kinetic energy means energy possessed by a moving body. When a body moves, when a dog runs, when a car moves, we can say that it possesses kinetic energy. So all the molecules inside the skeleton, there are millions and millions of molecules. Each molecules are in motion. But in a solids, that motion is just vibration. It cannot leave its position, that I will explain when we reach the molecular model. Okay, so the third character is they possess kinetic energy. That means they are in motion. The last one is there is a force between them. Each molecule have a force of attraction between them. So these are the 4 characteristics of molecule. Molecules are small in size. They have space between them. They possess kinetic energy and they have force of attraction between them. Now we can say that there are 3 states of matter. From class 4 onwards, you are studying the 3 states of matter: solids, liquids and gases. So here we are going to study the solid, liquid and gases under molecular model. Explanation of molecular model in solids, molecular model in liquids and molecular model in gases. So first it is molecular model in solids. Here you can see, suppose this is an ice cube. you can see lot of molecules inside the ice cube, but there is less space. You can see the space between these 4 molecules. So you can see less space in between the molecules. So the space between the molecules is known as intermolecular spacing. Okay, so in case of liquid you can see there is a lot of space between the molecules. So here this intermolecular spacing is more, and the third one is gases. So for example, I can show you in solid, as I told, this is solid, all the molecules are tightly packed. So the molecules are not allowed to move out because they have a strong intermolecular force of attraction. Here you can see 2 molecules. These 2 molecules have a strong force of attraction so that they are not able to separate. So you can see this car, this is a solid object. The entire car have millions of molecules in between inside this, but these molecules are not allowed to move because they have least separation, least distance between the molecules, as well as maximum force of attraction. Okay, but in case of liquids, you can see the liquids. We already studied liquid does not have a definite shape. It acquires the volume. It only have a definite volume. It acquires the volume of the container. But still you can see the molecules are free to move. When I just pour it, it may spill out. Because the molecules of liquid are free to move. Reason is that you can see here the space between the molecules in a liquid are more, so that the force of attraction will be less. If you have less attraction, the molecules are free to move. Okay, so that is the case of liquids. And the third one, gas. See the difference? Inside one container, I am just drawing a container. You can see the molecules are separated far apart and the force of attraction is least. So if you know the spray bottles, if you spray it, you can see the molecules inside the spray are free to move in this entire room. Okay, so this is because the molecules of the spray are, the force of attraction between the molecules are least. So now I am going to conclude that how this molecular model, defining molecular model on the basis of intermolecular spacing, intermolecular force. Okay, in solids have least or minimum intermolecular space but maximum intermolecular force of attraction. You can see both, they are kept near. In case of liquid, the space between the intermolecular molecules are more as compared to solids. That is, intermolecular force is more compared to solid. Intermolecular space is more and intermolecular force is less. So they have a tendency to flow. Third one, in case of gas, it have maximum intermolecular spacing, minimum intermolecular force. Force is less, space is more. So they are able to move as they wish. Okay, so these are the explanation, that is explanation of molecular model of solid, liquid and gas. And one more thing, I told they possess. So just now I told space between them, force between them, intermolecular spacing, intermolecular force. Here you can see one more thing, that is they possess kinetic energy. In case of solids, the solids have kinetic energy. The molecules of a solid have kinetic energy, but in solids they are not allowed to move. They will just vibrate. They will just vibrate and pass the energy to the next one. And again, by vibrating, this molecule will pass the energy to the next one. This can be demonstrated by a simple experiment. You know, this is a steel scale. When I light a lighter over here, within few minutes, you know what will happen to my hand, it will get burned. But actually is the molecule which gets heated up here, is it coming, starting their journey from here and reaching here? No. They are just vibrating, giving the heat energy to the next molecule, and again that third molecule, I am not going to heat it more. So you just imagine this is a scale. So when I heat it here, this molecule start vibrating. They are not allowed to move. They have kinetic energy, but they are not allowed to move. They can just vibrate from their mean position. So this energy is carried to the next molecule. Then this energy, this molecules will start vibrating, carried to the next. Then this entire steel rod, when I heat for 1 or 2 minutes, the heat energy will transfer from this end to this end. So in this case, in case of solids, molecules can only vibrate, but they can pass the energy. In case of liquids, they are free to move. They are free to move inside the container. Okay. But in case of gas, when we just press the spray bottle, you can see the molecules are free to move and they are inside this room. So these are the different molecular model, that is solid, liquid and gas. Okay, I think hope you all understood. Now we have a small topic called force of adhesion and force of cohesion. The force of attraction between the molecules of same substance. When we take water, and I'm just, you can see a drop of water. I don't know whether you are able to see it clearly or not. You can see the molecules of water are bind together with a strong intermolecular force. That is why this water makes a droplet. Can you see droplet? That is because the force of cohesion, force of attraction between the molecules of same substance is called force of cohesion. Now when I just tilt this book, you can see still few water sticking on this paper. Okay, you can see a small drop over here, drop over here, and all. That is called force of adhesion, force of attraction between the molecules of different substance. Here this is water and this is a plastic sheet. So there is attraction between molecules of different substance. Molecule of water is attracted to the molecule of the plastic. So this is called force of adhesion. So there are two types of intermolecular force. So intermolecular force divided into force of cohesion and force of adhesion. Force of cohesion means force of attraction between the molecules of same substance. Force of adhesion means force of attraction between molecules of different substance. Hope all of you understand the first portion. All of you please sit and read the textbook. I think if you don't have the textbook, try to buy the old books or listen it. Listen this class once or twice or thrice, and after this I will send you the next video in which we will deal with change of state. Okay, thank you for viewing the video.